isn't there a tension between treating something as just data, because that's what it is, it's just data about a thing, and treating it like an entity with its own semantics? Hi, my name is Eric Normand, and these are my thoughts on functional programming. So yes, I do think there is a tension, and I think that that's where a lot of functional programmers live, in that tension, that we recognize that we're dealing with information systems, which means that at the end of the day, it's just some data that we're dealing with. We're just processing data, we're storing it, we're transforming it, making calculations from it, all sorts of things like that. But we also recognize that this data is meaningful, that it's supposed to have some kind of semantics. So at the end of the day, an integer is not just an integer, it's somebody's height, or a string is somebody's name, and so it's not just a string. So there's a tension between these two things, and we have to live with that. I mean, all programmers live with this tension, and the question is, how do different languages deal with it? How do different paradigms, maybe the paradigm has something to do with it, maybe it doesn't. A reader or listener wrote in with a question that asked me to talk more about the tension between the two, and how I, in a previous episode, maybe a couple months ago now, I was talking about putting interfaces around your data so that you could treat it like entities. And this is very close, to a Clojure-specific recommendation, because in Clojure we tend not to make new types, new classes. We tend to use hash maps to represent our entities. And so if you leave it as a hash map, you leave it as data. And then the problem that you run into a lot is you have all these hash maps and you don't know what you have anymore. You just have a bunch of hash maps. Sometimes they're deeply nested, and people get into confusion. They forget what keys are valid. They forget where they're at, sort of in the tree of hash maps, the big nested data tree. They don't know what they've got at each level. So what I suggested there was that problem shouldn't happen if you carefully abstract your entities with interfaces. Meaning, someone put it really well at one of the Clojure conferences. I was in a conversation with him, and he said that he doesn't get into this problem too, that the problem is people create these big types. Like if you were going to describe a nested Clojure data structure as types, they would have this really big type description. It would be, a company has multiple people, and each person has an address, and the address has a street, and the street has a number and a street name, right? And so you're starting at the top. You are describing this whole path down into the tree, and that's just part of it, right? Like the address also has a zip code. It also has a city and a state and maybe a country. It's got all this information in it that is described from the top, right? Now what you want is something that is shorter, multiple short things. So you say a company has people, end. A person has an address, end. An address has a street number and a street name and a zip code, end. Right? So you have these short types that are easy to picture, easy to see in your head, easy to read, and you never at any point have to think down into them. right? You never have to think too deep into them. They're one deep, maybe two levels deep, right? I think the one is enough. And my suggestion was that you should start thinking of those pieces, those individual pieces, and what operations you can do to them. All right, so my suggestion was you take those entities, the company, the person, the address, and you think about the operations that make sense for those particular entities. So a company doesn't have any operations on it that can change a person's address. A person can change their address, but a company cannot change a person's address, right? There's a semantic barrier there. There's just a level of meaning where this can't happen. And that's where the entity boundaries come in, and that's where you put your interface. Now, that isn't to say that you still have the exact same nested data structure in the end. But when you have a company, you can only do those operations that you have specified for a company. So if you're like, oh, give me the list of addresses of all the people, that might, of all the employees, right? That might not be an operation on company. You would have to go and ask for all the people, and then you would get an address for each person, right? So you never have this problem of like something like a get in, where you've got this long path going in there. You should never know the path, because if you're starting at a company, it doesn't know 2 levels in that people have an address, right? Okay, so that was I'm trying to re-explain that situation and why I suggested that you should be thinking about an interface. Usually it's an interface made of functions, but it could just be, yes, and you can access these keys like functions, right? Like you don't have to like totally wrap it up. But by doing that, you're able to have the best of both worlds, the best of that tension. You can treat it like an entity. You can treat a company like a company, even though it's just a hash map. And you get to treat it like data. You get to treat it like a hash map. So all your functions like select keys, list keys, you can turn it into a seek of key value pairs. All of those things are still possible. So at the end of the day, you are still able to treat it like data, but you've also got, when it's at the appropriate semantic level, you can treat it like a company, right? Not treat it like a nested tree of hash maps. And so I think that what happens is people are acting at the wrong semantic level. When they get into this problem of, I don't know what I have anymore, I've got these deeply nested paths, if I change something deep in here, like let's say you change the person, you change address, and like you no longer separate out the street number from the street name, right? You just have one string called street 1, and you have another one called street 2 that you can put the apartment number in there or something. That's very common, right? And so you change the structure of address. Before, all of the code that deeply knew the whole path of keys from a company through the employees into the address and to the street number, those now have to be changed. You have to go find those things. And I'm arguing that they should never have existed because of that. Because you're coupling this address thing with a company. A person's address and a company just they're not related enough to justify knowing this path along it. So, they're working at the wrong semantic level. when they're thinking about it as a company with employees who have addresses, they're treating it like a hash map. That's a low semantic level. That's like the language level. They haven't built up another layer of meaning where it's a company with operations that make sense for companies. Okay? So that tension there is always there. What semantic level am I playing at? And it's your job as the programmer to always try to be separating these things out, these levels out. This gets into the stratified design that I've talked about before. But if you're treating an entity like a hash map, that's a smell, right? If you got these really long paths to get data out from a certain part of the tree, you're probably working at the wrong level. And I think that there's a law in object-oriented, I want to say it's law of Demeter, but I might be wrong. This thing where you're not supposed to ask for the company's employees' addresses, street name, right? You're not supposed to have this long chain of getters. That what you're supposed to do, if you need to do that, it probably means that there's a semantic operation for getting a mailing list for employees. Like employee mailing list it could be a valid operation on company, right? And you shouldn't be embedding this long chain somewhere else, right? You should just call the companies one place, the employee mailing list. So it's a similar idea that you're trying to work at the level of meaning where you're at in your problem. So you should be always asking yourself, is this a hash map problem? Why am I doing a lot of assoc and gets? Right? Why am I doing a lot of update ins and get ins? This is closure speak here. Why am I doing a whole bunch of array accesses, in JavaScript here, when I know this is a company? It should have operations that are specific to companies. And the thing in closure is that we separate out the behavior from the data. So a lot of times that you get into this trouble where you're thinking, well, it's just data, so let me just always treat it like data. Whereas in an object-oriented world, you have a place to put the behavior, namely the class, and you can start adding semantics into the class. The problem with that is it's all encapsulated, and you now no longer have all of the hash map semantics that you had before. All right, I'm starting to ramble now, so I'm going to sign off. My name is Eric Normand. This has been a thought on functional programming. Sorry for the light streaming in. I hope it didn't interrupt too much of my train of thought in your ears. And if you'd like to ask a question, I love answering questions. I feel like now I'm at the point in this podcast where I've got enough audience where I'm getting a regular stream of questions, which is actually pretty nice. So you can reach me on Twitter. I'm at Eric Normand. You can also email me, eric@lispcast.com, and find me on LinkedIn. Follow me if you're into the LinkedIn. Awesome. See you later.